this video on adding polynomials. By the end of this video, you should be able to identify like terms, combine like terms, use addition to combine polynomial expressions, and use addition to find the perimeter of a polynomial figure. All right, so let's take a look. Let's remind you, what is perimeter? Perimeter is found by adding together all of the sides. So when we have multiple sides, we're just going to add them together and it will tell us the total distance all the way around. So let's do a quick review here. Notice how all the sides of this figure are labeled. So to find the perimeter, we're going to add them together. So we have 20m plus 18m plus 20m again plus 30m. Okay, so I went through and I listed all these. These are all like terms, which means we can add them together. 20 plus 18 is 38, plus 20 more is 48, 58, plus 30 is 88. M is our perimeter. Okay, so let's try it again on the next figure. This one is shaped a little bit differently, but we have all the sides, so all you've got to do is I'm adding all of these numbers together. 9 plus 5 is 14, plus 4 is 18, plus 6 is 24, plus 8 is 32m. So these are found exactly the same. I just didn't write down all the numbers. 9 plus 5 plus 4 plus 6 plus 8. I added them all together and that gave me the perimeter. Okay, when we're going to add these polynomials together, there's a couple things we need to remember. We discussed this in the previous lesson. We need to combine like terms. And we need to be sure to write our final answer in standard form. So you want to be sure to combine like terms and write your answer in standard form. So when we're adding, that just means we're following what the signs are telling us to do. So let's take a look at our first one. This is very similar to the previous day's review that we've done. So I always kind of take a look, do I have first? I have a 3 with a K. Do I have anything else that just has a K? And I go across and go, look, 7 is with a K. So these guys are like terms, they're going to go together. 3 plus 7 is 10K. Okay, now let's try the next one. I have just a 4. It's a constant because it doesn't have a variable. It's a positive 4. I'm looking for any other constants. There's one right there, plus 3. Positive 4 plus 3 is plus 7, and they don't have any variables, so that's all we're going to do with that. And then this last term doesn't have, I'm just going to underline him twice. He doesn't have anybody to combine with, so I'm going to write plus 5k squared. Now, I combine like terms. The next part said write in standard form. So that means, remember, the largest exponent to the smallest exponent. We're looking at the degrees here. So when I look, this term has a 1 on the exponent. This term doesn't have an exponent because it doesn't have a degree because it doesn't have a variable. 5k squared, that's the biggest exponent. So we're going to say 5k squared is going to go first, and it's positive because in front is positive. The next biggest exponent is k to the first. So I'm going to say plus 10k because that's a positive 10. And the last one is plus 7. Remember, your constant, or your number without a variable, it's always going to be the last one because it does not have a variable. So it always comes last in line when we're putting our degrees in descending order. All right, let's look at the second one. Just like when we were working on previous ideas, you got to remember, you got to take care of your distribution first, your multiplication. I see here that I have a 9 next to a parentheses. That means we're going to be doing some multiply, so I'm going to distribute it through. So we're going to have 9 times 4x, which gives us 36x. We have 9 times 7, which gives us 63. That ended the parentheses, so I'm done with that multiplying. So I'm just going to, at this point, just bring down the rest of the numbers, and then I'm going to look for like terms. So similar to what we did over here, I have 36x And I have another single x term right there. So 36 plus 11 is 47x. And then I have two constants. I have a 63 and I have a 2. So 63 plus 2 is plus 65. And that's it. That took care of everybody. So we combine our like terms. Now you just check for standard form. So you got to look for the variable with the biggest exponent. Well, there's only one variable. This is the x. So it has the biggest exponent and then your constant. So that is your final answer. All right, so this is kind of what we were dealing with originally. Now, take a look at this. It doesn't act any different. It just looks a little bit differently. See how we have a parenthesis plus a parenthesis. There's no numbers in front of these parentheses to be distributed through. Technically, there's a 1, but multiplying by 1 is not going to change anything. When you have a plus sign between parentheses like this, what that means is to go ahead and you can combine like terms and then write in standard form. So the addition of polynomials is a lot easier than when you don't have to really pay attention to a lot of different things going on. We're adding, so we can just combine like terms. So let's just take a look. We have p cubed, and so I'm going to look, or p to the third. I'm going to keep looking. Here's a p to the third. It has a -5. I keep looking. There is no other p to the third, so I have, remember that's a 1. 1p to the third minus 5p to the third is -4p to the third. Okay. Now I'm going to just take the next one in order because it's easy to kind of keep track. P to the second, and I'm going to follow along. I'm looking for p to the second, and I don't see any other p to the seconds. So that means he's just going to come down. There is no one for him to combine with. Okay. I'm going to pick up the next guy. He is 9p. So I'm looking just for a single p. Oh, I have a -8p right here. So I have 9p minus 8p is a positive 1p. A lot of times you won't see that 1 written there. You can leave it off. And then for our last one, I have a constant. I have -6. And when I come across, I got another constant right here, a positive 1. So -6 plus 1 is -5. So when we look, we want to look for standard form. So we've combined all our like terms. Standard form is largest exponent to smallest. So when I'm looking at this, I have an exponent of 3, an exponent of 2. This guy actually has an exponent of 1, and the -5 has no exponent. So if you look, it's actually in descending order. 3, 2, 1, none. So this is in standard form. That is our final answer. Okay, so number 4 would be the exact same problem. We would just combine our like terms. Number 5, we're getting a little bit bigger, so we'll skip 4. Let's look at 5. It doesn't matter how big this exponent is, we treat these exactly the same. Okay, so I'm looking, I see 6y to the 5th. I could say 6y to the 500th. It doesn't matter. You're just looking for something that matches y to the 5th. So I'm going to follow along, and I don't see anything else that's y to the 5th. That means he's just going to come down. It's got no one to combine to, no like terms. He stays the same. All right, now I have a positive 2y to the 4th. So I'm just going to look for y to the 4th. There's one. This is positive. So 2y to the 4th plus 3y to the 4th is 5y to the 4th. Okay, and just keep on moving across until we've dealt with everybody. We've got a -21y cubed, so I'm going to look for another y to the 3rd. There's one right there. We got -21 minus 1 more will be -22y to the 3rd. And then lastly, we have this constant, and he doesn't have anybody to combine with. That just means he comes down just the way he is. He's going to remain unchanged. So when I look at my degrees, I notice that they're already in descending order. The biggest one is 5, then 4, then 3, We don't have a 2 or a 1, but we have a none. So they're in order biggest to smallest. So that makes this our final answer. One last one. Try this. What I'd like you to do is just pause the video and see how you do, and come back once you're done. All right, so here's the final answer. 5c cubed plus 2c squared plus 3c minus 2. Now how I got that, they're adding, so I can just combine like terms. I have a c squared, and I didn't see any other c squared, so I'm just going to bring them down. 2c squared. I move on to c, and I'm looking for any other c, and I don't see one. So he remains unchanged, plus 3c. I got a positive 5. It's a constant. I'm looking for another constant. I have one right there at negative 7. 5 minus 7 is negative 2. And then the only guy that hasn't been dealt with is that 5c cubed. He's positive, plus 5c cubed. Now, this is all out of order, so all you had to do from here is look to get your term with the biggest exponent. We'll go first. That's your 5c cubed. And then your next one is the 2, then the 1, and then the none. All right, I'm hoping that was pretty helpful for you. Let's take a look at the perimeter on the back. So remember, when you're finding perimeter, you're just adding up the sides. So that's what we were doing before. We just didn't have a figure, and this time we do. So when I look at number 7, I see that there's 3 sides. They need to be added together. So I'm going to say this side, which is 3x plus 8, plus the next side, which is 4x minus 1, plus the next side, which is 5x plus 2. Now, because we're adding, I wasn't worried about parentheses, and when we start subtracting, we'll talk about that, how we have to be careful, okay? But we're adding, so we can just write down exactly like they are and combine like terms. So I've got 3x plus 4x plus 5x. So 3x plus 4x is 7x, plus 5x is 12x. And then I have positive 8, negative 1, positive 2. 8 minus 1 is 7, plus 2 is 9. So the perimeter of this triangle is 12x plus 9. It's the same thing we were doing before. So let's take a look at it again. Triangle, perimeter, add together all the sides. When we're just adding, we don't have to worry about anything but getting going. We can just add, and we'll understand that a little bit more when we subtract. So this really says 2x squared plus 9x minus 10 plus x squared plus 4. So 2x squared, I'm looking for any other x squared. I see one right here. So I got 2x squared plus 1x squared is 3x squared. I have a 9x, and I don't have any other 9x's, so it just comes down unchanged. And then I have a constant of negative 10 and a positive 4. So negative 10 plus 4 would be negative 6. All right, and it's in standard form. 2, 1, none. We're in order, so we're good to go here. Now, these are going to work, the next two are going to work the same. You just got to think about what it's telling you. So our first one, there's no words here, but we're finding perimeter because that's what our directions are saying out here. And I give you a rectangle. 2 sides are labeled. You have to remember that if this side, if we're talking about a rectangle, if 2x minus 3 is that left side, that means the right side is also 2x minus 3. Because you want to add together all the sides, not just these 2 sides. We need all 4 sides added together. If this bottom side is 4x minus 7, that means the top side is 4x minus 7. From here, it's no different than when we did the triangles. We can just add together each side. So we have a side that is 2x minus 3, plus a side that is 4x minus 7, plus a side that is 2x minus 3, plus the side that is 4x minus 7. From here, it's just combining like terms. So 2x plus 4x is 6x, plus 2 more is 8x, plus 4 more is 12x. So you have all these like terms. All of these need to be combined together, all of those. All the rest of these are constants. So I have a negative 3 minus 7 is negative 10, minus 3 more is negative 13, minus 7 more is negative 20. So the perimeter there is 12x minus 20. All right, one last one. This one just says words. It didn't even give you a picture. Find the perimeter of a rectangle field with a length of 3x squared plus 4x minus 8 and a width of 7x squared minus 10. So anytime I have a word problem telling me about a figure and they tell me the shape, I'm going to draw the shape. It said a rectangular field. There we go. There's a rectangle. It said the length is 3x squared plus 4x plus minus 8. So I'm going to just pick a side, 3x squared plus 4x minus 8. And a width, so this is length, so that makes the other way going the width of 7x squared minus 10. So the same rule applies here. It's not to find perimeter, we have to add together all four sides. So you need to know all four sides. In a rectangle, if one side is a length given, the opposite side is the same length. Same here. We have this is 7x squared minus 10, so that this is also 7x squared minus 10. You want to add these all together. I'm going to show you a little bit of a shortcut. Notice that there's 2 of each one. So I'm going to say 2 of the 7x squareds minus 10, because there's 2 of them. And I want to add to it 2 other sides that are 3x squared plus 4x minus 8. Now, we could have added all the sides like we did on this last one. We could have listed them all out individually and combined like terms. This is just a slightly shorter way to show it. Okay, so we can see how this is a 2 by a parenthesis. That's your distribution that you have to do. So 2 times 7x squared, 14x squared. 2 times negative 10 is negative 20. Same here. You've got this 2 distributing to this whole parenthesis coming after it. So 2 times 3x squared is 6x squared. 2 times 4x is 8x. And 2 times negative 8 is negative 16. Now, we're not done. Remember, you have to combine like terms and write in standard form. We just finally got it in a way that we could do it easily. So we have 14x squared. I'm looking for any other x squared terms, and that's it. So 14x squared plus 6x squared is 20x squared. I got a negative 20 and a negative 16. So I have negative 20 and negative 16 is negative 36. And then I have a positive 8x. Okay, so we need to put this into standard form. All right, so the x squared, that's the biggest exponent, 2. This one has none, that one has 1. So the 20x squared will go first. And then we have, this is a constant, it has to go last. Our next biggest exponent is 8x. So we have plus 8x minus 36. That's our final answer. So it looks like a lot of work. It's but what we just did here was kind of a shortcut because there was 2 of the same sides. We just multiply the sides by 2. We easily could have written them all out and just added them together and gotten the same answer. All right, so hopefully that was helpful. Please let me know if you have any questions, and I'll see you in class.